This is where we left off in our last video. I had erased some of the work that we did in that video. But let's look at this rectangle here now. Not rectangle, this triangle here. Let us say that you're required to find the area between x axis, so x axis, the line y equal, say y equals 6, x axis y equals 6, and the curve y is equal to, let me see now, 3x. Y is equal to 3x. Alright? Now, if that is so, then you would calculate how far up y goes. The line y equals 6 is this line. So you'd have 0 on the left. Let me erase this x1 from here. You have 0 to 6. Or how you know how far x goes to the right, it's 6. Because the line y equals 6. No, not y equals 6. X equals 6. My mistake. X equals 6, I should say. The line x equals 6. Right. Alright, so let's look at that again. You're finding the area between x-axis, which is this line x equals 6, which is this line, and y equals 3x, which is this line here. Alright? Now, you want to find out how far up y goes. Right? If you were to do it by the usual method, half base times height, you'd have to have the vertical height. So you would say this goes up to 3, 6, 18. Right? So this would be 18. So what you would say now is that area is equal to half times 6 times 18, which is half of 18 is 99654 square units, right? But what we want to do is to do it by integration, double integration, instead of the half base times height. So let's see how it would work. Alright. Now let me just erase the 18 here. You know, it's supposed to be 54 when I finish. I already wrote down 54. But let's see if that is what you're going to get. Now, what you're doing is you're summing up from x equals 0 to x equals 6. And it is the width that you're summing up. The delta x is, right? So delta x. You're also summing up the height from y equal 0 up to a certain point. I'm not going to write it yet, of delta y. Now we're going to put these together, but what's going on here? I didn't put any specific number here because how far up it goes is not a specific number like in the case of the rectangle. Here it goes up a little, here it goes up more, then more, then more, then more. Now what is the height here? It is in fact the formula. What did I say it was? 3x? Right, y equals 3x. So this mx is not mx anymore. it is 3x because we put a number to it now. So what we're doing, if we consider stacking the small squares up from the floor up to the top, we're looking at the sum from y equal 0 up to y equals 3x of delta y, because what we're adding up when we stack from the floor up to the top is the height delta y. After we stack up the height, then we go sideways and stack them up, pile them up sideways. So we're summing this, all of this we're summing up now, from x equals 0 to x equals 6 of delta x. But what is the function that we're using? Well, in this case, we consider it as 1, as usual. Alright. Now, as these little squares get smaller and smaller, delta x approaches 0, delta y approaches 0, we need more and more of them to add up. So as they approach 0, where is the integral from y equals 0 to y equals 3x of d, not delta, dy, and the integral from x equals 0 to x equals 6 dx. You see that? Now let's see how it goes. When you integrate 1 with respect to y, you get 1. Because remember, 1 is really 1y to the 0. And then when you integrate it, you get 1y to the 0 plus 1 over 0 plus 1. You should remember that by now. So it's 1y to the 1 over 1. So it's really y. And the boundaries are from 0 to 3x. And you put back this same integral here, because you haven't done that one yet, from x equals 0 to x equals 6 dx. Alright, so what's going to happen here now? You have 3x, y becomes 3x, minus y becomes 0. You integrate from 0 to 6, from x equals 0 to x equals 6 dx. When you integrate 3x with respect to x, what do you get? Well, it's x squared over 2. So it's 3x squared over 2. And you're going from 0 to 6. So what you have now is 3 times 6 squared over 2 minus, well, 3 times 0 squared over 2 is just 0. So 3 times 6 squared over 2 is going to be 3 times 6 36, and then half of 36 is 18. 3 by 18 is what? 3 is 24, bring down the 4. Carry 2, 3, 1, 3, 4, 5. 54 units squared. Alright? Same thing with that for the half base times height. But this time we did it by double integration. Alright? So we look at something else in one next video, at another shape in one next video. So I'll see you then.